Hello friends, welcome to my channel. So let's have a look at problem 2330 together. So this is a new problem, valid palindrome 4. So for this problem, we're going to share a two-point solution. So we shall first read through the statement and then analyze the idea and procedure, and finally we share the short code. First, let's look at the statement of the problem. We are given a zero-index string S consisting of only lowercase English letters. In one operation, we can change any character of S to any other character. Return true if we can make S a palindrome after performing exactly one or two operations, or return false otherwise. So let's look at example 1. So in example 1, so we see A and A equals in the two end, and B and B equals in the two end. The C, D in the middle are not equal, so we can change C to be D or D to be C. In other words, we need only one operation to make S a palindrome, so we return true in this case. In example 2, so this is already a palindrome, so we need to return true. In example 3, actually we look at the distinct characters and the length of S, we know we need to return false. So with that said, let's look at the constraints about this problem. So the constraint is about the length, and it's greater or equal than 1, less or equal than 10 to the power 5. And S consists of only lowercase English letters, so that's actually not so essential for the problem. So now let's look at the method we're going to share here. The method is the standard two-pointer method, so we are going to practice such idea again. So the idea for this specific problem is that we check how many operations we need. So the specific procedure is as follows. So we use two pointers, start from the very beginning and the very end. So we compare if they are equal. So if they are equal, we are going to shrink the left pointer and the right pointer simultaneously. And so then we compare again if they are equal, so we shrink it again. So if they are not equal, we need operation to make it equal, so that we can check the number of operations for S applied on S to make it a palindrome. So here we check when L equals 2 and R equals 3. They are not equal, so we need one operation. And then we continue. So then L would be larger than R, so we stop. So that's a very standard linear procedure. With that said, let's look at the short code. So first, I'm going to initialize the pointer. So 1 is 0, 1 is the length S minus 1. So in other words, the two pointers are at the two ends of the index. Then we're going to make a count. The count basically counts how many operations do we need to make S a palindrome. Then we start the traversal or comparative procedure. So while L is less than R, so we are comparing different indices. If the indices L and R are the same, so for sure the characters corresponding are the same. So if SL does not equal to SR, so we're going to increment the count by 1. So that's standard. So then in between, actually we can add a stop condition. This is the early stop condition. So basically check if count is greater than 2, meaning that we cannot make a palindrome using less or equal than 2 operations. We're going to return, right? So we're going to return false. If count is greater than 2, we're going to return false. And then we're going to shrink L and R simultaneously, shrink the scope within them. So we're going to increment L by 1 and decrement R by 1. So with that said, we are ready to return the result. So if so, we are going to return true. So in other words, after the while loop, there's no return of false. We're going to return true. So with that said, actually we can check the special case. It passes the special case example 1. Now let's check the generic case. Yeah, it passes the generic case. So actually for each of the examples, we can try to print out the final state of a count. In other words, the number of operations we need to make it a palindrome. For example, in example 1, count will be 1. And in example 2, it would be 0, right? And in example 3, let's check that. So let's see. It's already returned false. So for this one, let's do things like this. Let's print. So in this example, actually, it needs 3 operations. So print count. So 1, 2, 3. So, but at most we need 3 because there are 6 characters. 3 pairs. So that's about it for this problem. Thank you very much.